One of the ways we will learn how to summarize data and really use computer systems to find out information about the world is the TI-84 graphing calculator. That's Texas Instruments graphing calculator. This particular emulator we'll be using is the TI-84 CE. So what we will be doing is learning how to enter data into a list and also to calculate one variable's statistics. Like with any tool, you need to know how to interpret what you find out and verify if it's reasonable. So this is, one step to make calculations easier so you don't get bogged down in those while you are figuring out how to summarize this data. Are you ready? You in for a good time? Let's go. The following data I collected from 14 part-time San Diego County Community College instructors. Part-time, adjunct, associate, they're called different things at different colleges, but at every college, these people are a valuable resource. And often what happens is they work at 2 to 3, maybe even 4 colleges, and they drive a lot of miles and thus spend a lot of money on gas. So here are some of the numbers I collected for what these 14 instructors spent on gas during their mission to educate you. And let's check out some measures of center and spread. So, grabbing our graphing calculator, this is considered to be raw data. I made this in 2 columns just so that you would find it easier to read. So this being the table this table here is in 2 columns just to make it so it's not one long column. The only variable is how much money these different instructors spent on gas over the month of October in 2017. So bringing up our graphing calculator, yes, in real life, you'd probably be using Excel, and we'll also explore how to do this in Excel. But just for reality's sake, instructors often will use a graphing calculator of some sort so that you can use it on a testing situation and they don't have to monitor to see if you are Googling a tutor or something while you're taking your test. So here we go. This is an emulator, the TI-84 Plus CE. And what we do first is we go to the stat menu. So take a moment to look around and see if you can find the stat menu. I'll give you a hint. The words are in white on my screen. Here we go, good. Stat menus here. And look, it gives us these menus. One thing I had a hard time with when I first started using a graphing calculator was people would talk about highlighted menus. And to me, this seems sort of low-lighted since the highlight is in black and the printing is in white. So if that's an issue for you, hopefully that helps you. Otherwise, maybe you can just think I'm crazy, which I probably am. What we are doing first is we are going to edit a list. So here we're on the edit menu is highlighted, and number 1, we're editing this list. We don't need this other stuff at the moment. So we're going to hit enter. And oh no, look at this. These lists have stuff in them. So one thing you can do is you could go on to L3, meaning list 3, or so on and so forth. But the problem is the default will always go to L1 or L1 and L2 if you're in two variables. So it's nice to be working with those two lists. To clear L1, if you highlight or lowlight L1 and then you hit clear, don't hit delete, hit clear, then you will clear the list but not the column. So you hit clear and then enter, and like magic, it starts anew. Let's also do that with list 2. We're not going to be using list 2, but it'll be nice not to have any, static in our way. All right, so now we know we have 14 entries, so let's go ahead and enter them in. So our first entry is 225. Look at the bottom here because that will tell you if you have made a mistake or not. And then I'm just going to keep entering these. Hopefully you're doing it along with me so you're not bored. I thought it would be illuminating. See how illuminating that is? I missed a 0 there. So you always want to double check what you're inputting. Again, another error. 95. 160. 250. 80. That person must have a hybrid. And look, it turned up as 8. I meant to hit 80. So what I've been doing is using my keyboard, but you know what? Maybe what I ought to do is use the mouse to actually hit these keys. So I'm going to go back and hit 80, enter. Now we're on the next column, so 240. Again, the reason there are 2 columns in this information is just to make it look prettier and more palatable to the reader. I don't know if that's palatable or palatable. I can read things, but I have trouble pronouncing them. You can let me know in the comments. If you make a mistake, that's okay. You can arrow back or arrow down after you're done entering. All right, here's our last one. Now we knew we had 14 data points, or actually data values, since there's only one coordinate. And so here, notice that we're on L1 parentheses 15, which means the 15th row of the first list. So we're good to go. So now, it's not, it's nice to double check the data. I double checked it as I went along, but you can go through, back over here, and go down through and match up what you entered in. And everything's looking great so far. Okay, so I think we're good to go. Now, we have entered in the data, raw data, because it's not given in summary statistics, which we're about to find. We're given this raw data. We entered it into list 1. And so now we quit out of there. So to quit, the quit button is here. So you hit second and then mode, which takes you to quit. All right. And then it's blank. Oh no. So now we want our summary statistics. So our summary statistics for this one variable list what menu do you think we go into? Beautiful. Stat menu. But this time, we don't need to edit a list. We need to calculate. And how many variables do we have? Right, one variable. So we can just hit enter, or you could hit the number 1 if you want. See how it defaults to list 1? That's exactly what I was telling you. So that list 1 is what it defaults to. We're good with that because that's what we used. And then once calculate is highlighted, so once it's blinking on the calculate, you hit enter. And lo and behold, just like magic, we get the one variable statistics. So let's figure out what all this stuff is. What I'm going to do is go through one by one, and some of the stuff we're not using for this exercise, but some of it we are. Unfortunately, it doesn't have all of it in one screen, so I will go ahead and copy and paste the first one, and then I'll copy and paste the rest. So, by the way, this is a really great tool. It's in the accessories menu of Windows. It's called the Snipping Tool. So it'll basically capture anything that you want on the screen. So I'm clicking at the corner, and I'm going to go down here, and look what I have. So I'll copy this onto our page. And by the way, it's free if you have, any Windows machine. I have dragged it here so that it's always accessible to me. And now let's go back to our calculator and let's get the rest of the stuff. So what I'll do is I'll start the copy again at quartile 1, just because that's something you might be interested in soon. All right, so here we go. So here, let's talk about what all this lovely information means. So here, I wonder if this will cover it up. Yes, let's cover up that quartile 1, just so that it looks like a seamless, that wasn't seamless. Just so it looks like a seamless list, which it does. So here we go. The data we entered in here gave us these summary statistics. So the summary statistics are X bar represents the mean of this data. So X bar traditionally means the mean of your sample data. Which means, no pun intended, you find it by adding up the data and and dividing by the number of data values in this case. So literally what this calculator did is it added up all of these data values and it divided by what? Beautiful, 14. Okay, so Summation x means it's the sum before you divided by that 14. So if you added up all these data points, you would get the 2405. Now, summation x squared is something that we use in finding both of these things, or something we use in finding the variance or standard deviation, which measures spread. So mean, arithmetic mean, measures center of the data, and standard deviation and variation measure spread. So Sx here is the usually denoted like this, S sub x, and that represents the sample standard deviation, which measures spread. Now, sometimes we know what it truly is, and so sigma sub x represents the population, so the true spread, the true population standard deviation. Oops. And then you get some other information as well. So this particular problem, we were tasked with looking at the measure of center and the measure of spread. So we have this measure of center x bar, which is the arithmetic mean, which means adding them all up and dividing by the number of data values. Now, mu x would be if it wasn't just from a sample, if it was the actual population. So that would be the population mean. So it's still the situation where you add them all up and divide by the number of values, data values, but it's more powerful because you know it's from the population. So for example, in our statistics class, if our population was everybody in the class and I found the average of, say, your first exam scores, then I would have found mu, which is the population mean. If I randomly picked 10 scores from your class and I found the mean of that, that would be the sample mean. Groovy? Awesome. Same thing with sample standard deviation versus population standard deviation. Anything that's a population measure or a population statistic is more powerful, but in real life often we don't have that. So we adjust certain things so that we can get the ability to, positively, well, not positively, but the ability to predict things or to confidently give some measure of center or spread. Groovy? All right, so soon we'll be moving on to things like box plots. Okay, so box plots utilize quartiles, and so that's when you might be using stuff like this. Median is another measure of center, and it's really powerful when the sample mean is very close to the median, because that tells us our data is not skewed. So keep that in mind for the next time. And at the end of the day, our measure of center that we have from the graphing calculator is, sorry, are the X bar which is the arithmetic mean. And that was equal to, I'll go to the nearest cent since we're talking about dollars. That is approximately $171.79. That's a lot of money in gas, isn't it? Appreciate your instructors. We work hard for you. We also have the median. Okay, now the median measures the center from an ordered list, and it literally takes you to the center of the data. Like if you're, going down a row in a movie theater and you want to sit in that center seat, that's what the median does. So the median was that's usually the notation for median. And that was equal to $167.50, which isn't that far away. So those are our measures of center, and our measures of spread. We just have two, and I'm just going to say measure of spread, because you're going to be the one that knows if you entered in population data or sample data. So measure of spread, if you have sample data, which is a more typical situation, is SX equals approximately 67.41. So $67.41. If you happen to know that you had population data, that measure of spread would be $64.96. So spread measures variation, and we'll be moving into those topics soon. But this will give you a start and some information on how to enter data into a list, which we use a lot in statistics. So have a fabulous day, or evening, or morning, whenever you're listening to this. This is Shannon Myers, signing out.